So we're continuing our discussion on the specification sheet talking about Thiele small parameters. And next is BL. The B refers to the flux density that's in the gap and near the gap, and the L the length of wire that is in the flux field. So if I draw a simple cross-section of the gap, we have flux, magnetic flux that travels across, and there's a little bit of fringe. The voice coil is wound on its former and has a number of turns. Typically we see voice coils that are taller than the gap, occasionally equal height, and sometimes even shorter. So the BL is flux and length of wire that is intimate to the flux field. The linear X max refers to the relationship between the gap height and its fringe field and the length of the voice coil, or the height of the voice coil. So we typically have an overhang, and if we subtract the gap height from the overhang and divide by 2 and add a factor for the fringe field, we'll come up with a linear X number. X defining excursion. There are other X max numbers that have come into play since Thiele small defined the original Thiele small parameters. So I won't talk much about them now, but I do want to say there are mechanical limits where you will have the coil would strike the back plate or the suspension cannot move any further. And there is an inductance limit. So our next parameter here, LE, is a definition of inductance. Typically it would be the inductance at 1 kilo. And thinking about the voice coil, it is an inductor. It's an inductor that is in a field around iron, and as that coil moves, its inductance actually will change a little bit. But for the specification sheet, we usually define inductance at 1 kilohertz. So next on the Thiele small list is reference efficiency. And this is an efficiency calculation measurement based on power in versus power out. And it is a simple conversion defined in percentage. What we see in pro loudspeakers is a reference efficiency typically in the zone of 1 to 5%. In compression drivers, especially when they get attached to horns, it can be considerably higher, 20, 25, and theoretically even to 50% efficiency. The woofer efficiencies are very, very low relative to many other kinds of mechanical devices, like an electrical motor that would run at a steady RPM and, say, run the fan in a furnace, which can run at 85, 90% efficiency. Loudspeaker motors are very, very poor. And there's a couple of reasons for this, but one of the primary ones is that the voice coil gets hot and it reduces the efficiency. But mostly it is about the interactions of the flux and the mass that the motor has to move in, thinking about a very large gap of magnetic flux that is not as high as we would like it to be. Sometimes reference efficiency is confused with sensitivity, and I'm sorry to say, even some of our spec sheets have a couple of errors where we have defined sensitivity and our reference efficiency in a confused way. We're fixing it as we go forward, but efficiency is defined in percentage, and sensitivity is defined in decibels, sound pressure level in decibels. So sensitivity should be written as a number of dB SPL. We want to define a distance. Typically we will use 1 meter, and power, 1 watt. So you'll see SPL, watt, meter. This does not mean that we measure every loudspeaker with 1 watt and a microphone at 1 meter. But for the specification sheet, we will convert so that we have a standard and we can compare different loudspeakers. So, hypothetically, I'll measure one loudspeaker with 10 watts at 10 meters and convert that to what sound pressure would be with 1 watt and 1 meter. Or another one, if it's a subwoofer, we might go to 10 meters or 20 meters or 30 meters in order to have a very different kind of measurement. But again, we'll convert it back to 1 watt at 1 meter. So finally, we'll come around to Q. The Thiele small parameters have 2 Q factors. Mechanical Q we define as QMS, and electrical Q as QES. And together, we sum them to have a total Q referred to as QTS. Q is a complex topic. It's something that in electronics and electrical systems is, I would say, somewhat understood differently than in loudspeakers, but basically the Q is defined on the mechanical and the electrical interactions, and we will talk more about that in future videos.